All right, we're going to do some more word problems in section 3.5 that will help us solve linear equations. So for the first question, we'll provide some suggestions on how to proceed. Of course, if you can think of a different way to solve the problem, that's fine. On the way to the airport a few years ago, my wife hit a huge hole in a construction area and damaged the front right wheel. So they put on the little donut, and the temporary tire forced us to decrease our average speed by 15 miles per hour. So however fast we were going, now we have to go 15 miles per hour slower. But they're not going to tell us how fast they were going in miles per hour. They're telling us that it is a 39-mile drive, 39 miles to get to the airport, and it usually takes 45 minutes. How much time should we budget to get home from the airport? All right, well, so we want to know really how many miles per hour we're traveling on this temporary donut. So we were traveling 39 miles in 45 minutes. So if we want to change this to miles per hour, we need to change this 45 minutes to 3/4 of an hour, 0.75 of an hour. So that becomes, we're going to travel 39 miles in 0.75 hours. That's how many miles per hour. So when you do 39 divided by 0.75, we were traveling 52 miles per hour. That's how you can make it 39 miles in 45 minutes. Going 52 miles per hour. So what is the usual speed described by the problem? That is usually 52 miles per hour. The question here was, how much time should we have budgeted for the drive home from the airport? All right, so if you normally travel at 52 miles per hour, 52 miles per hour minus the 15, we have to slow down by 15 miles per hour. That means our new travel rate is 37 miles per hour, going slower on the donut. So 37 miles per hour. So if we have 37 miles in 1 hour, let's go ahead and how much time would it take to budget for the ride home? So if we have 37 miles per hour, we can also flip that in 1 hour. I can travel 37 miles. That's the nice thing. Remember, these equal 1. So it's a 39-mile trip. I'm traveling at, rather than miles per hour, do hours per mile. This is my distance, and this is my rate. But now the miles will cancel, and when I multiply across, I'm going to have 39 hours divided by 37, which is basically 1.05 hours. It's going to take a little more, pardon me, than 1 hour to get home. Let's look at number 4. This describes this type of marathon, the Barkley Marathon. This is a race so grueling that often nobody actually finishes it. It's a loop, 5 loops of 20 miles, through the mountains of Tennessee. For those who make it to the last lap, the racers go in alternate directions, which means, of course, that they'll meet somewhere in the middle of the last lap. Okay, so let's take a picture of this. 20 miles an hour loop. 1, 2, 3, 4. Okay, so that's 80 miles that they've gone so far. So for the last 20 miles, the first runner will start running this way. And for the last lap, the second runner continues running this way. And if there's a third person that makes it, he'll start running this way. So that means these two runners meet somewhere on this last loop. So here we have right here, let's say that only two racers make it to the last lap, and it's close. In fact, both start the last loop at the same time. Okay, so they get here at the same time. One is going to go this way at 2 miles per hour. And that, of course, means the other guy is going to go this way, and he's traveling at 1.92 miles per hour. This guy's traveling faster than this guy, but it's pretty close. The question is, how many hours would it be until they meet? And so they gave us a hint here. Use a letter to represent the time that they meet. Then write the expression for the distance traveled for each racer. What do their distances have to add up to? Well, if this guy's going this way and this guy's going this way and it's a 20 mile an hour loop, the distance of the 2 mile per hour guy plus the distance of the 1.92 mile hour per guy has to equal 20. So the distance of this first guy, distance equals rate times time. He's traveling at 2 miles per hour for a certain amount of time. This other fella, he's traveling a little slower. He's going at 1.92 miles per hour, but it's for the same amount of time. These two distances added together have to equal 20 because that's what the loop is, a 20-mile loop. So 2t plus 1.92t is 3.92t. And if we want to solve for t, we divide both sides by 3.92. And we get the time is about in 5.1 hours. In 5.1 hours, this 2 mile an hour guy is going to meet up with this 1.92 hour per mile guy.